We are going to go over the rules for identifying significant figures. So our first rule is any non-zero integer is considered a significant figure. For example, if you have the number 2.58, none of these numbers are zeros, therefore they're all significant here. Okay, so again, anything, it can be 473. This would have three significant figures. So any non-zero integer is considered a significant figure. Pretty straightforward. Rule 2 says that interior zeros are significant. So that means any zero that's in between two significant figures are significant. So like if you had a number like 507, now you have a 0, but it's between the 5 and the 7. So that 0 is also significant. So again, here you have three significant figures. Or if you had a number like 6003, again, we have two interior zeros, and they would both be significant in a number like 6003 because they are in between two significant figures. Also, like with the decimal point, you could have something like, again, these zeros here are in between numbers that are significant, between the 75 and the 4, so they too are significant. Okay. So our third rule is that leading zeros, zeros to the left of the first non-zero digit, are not significant. They're just going to help us figure out where the decimal point is located. So for example, if you had a number like 0.000031, so all of these zeros are leading, okay? They are not significant, okay? They're only helping us figure out where that decimal point is. So in this number, there are only two significant figures. Okay. Oops. So our fourth rule is that trailing zeros are categorized in different ways. So these are zeros that come at the end of a number. So we have a few kind of sub rules here. So trailing zeros after a decimal point are always significant. Okay, so if we had something like this, these zeros are after a decimal point, and so they're going to be significant. So in this 41.00, that's four significant figures. Okay, if we had something like these zeros are leading. Okay, remember, they only help us figure out where the decimal point is. They are not significant. Okay, but these two are trailing. Okay, they're after the decimal point and they are significant. So this number would have four significant figures: the 8, the 1, and then these two trailing zeros because they're after the decimal point. Again, the zeros here, they are after the decimal point, but they are not trailing, right? They are leading. They're in front of any non-zero number. Okay, so another sub rule here is that trailing zeros before a decimal point and after a non-zero number are always significant. Okay, so let's do like, if you had something like this, these are before a decimal point and after a non-zero number are always significant. Okay, so again, these two zeros, they come after these numbers, after non-zeros, and they're before a decimal point. Plus we have this one that goes with our first sub rule. So here we have 1, 2, 3, 4, 5 significant figures with this number. Trailing zeros before an implied decimal point are ambiguous and can be removed by converting the value to scientific notation. And this is really going to be helpful. So like if we take that same number we saw, right, but we don't put a decimal point, something like that, just 2100, well, now we don't really know. It's ambiguous. That could be significant or it couldn't, but we could really be clear in our communication here if we converted this to scientific notation. So we could report this number either as 2.1 times 10 to the third. And now you can see we only have 2 sig figs. Okay. Or let's say we use a really precise instrument to measure this, and we know it's actually 2,100 and whatever our units may be, okay? And so when we convert it to scientific notation, we leave those zeros in there. In this case, then these are 4 significant sig figs. So using the scientific notation really helps to remove any ambiguity and be really clear about how precise we were in our measurements. Okay. And our last kind of sub rule in this category, trailing zeros, is that if there are trailing zeros after a number and there's a decimal point is added, we're going to say that that signifies that they are significant. Okay. So if we have that number 2100. And we put a decimal point right there, then we are going to say, okay, well then those zeros are significant. Okay, so that would be 4 sig figs. But if there was no decimal point, then it would be 2 sig figs. Okay. All right. And our last rule when it comes to identifying significant figures is that any exact number or conversion factor that are exact, they don't count towards the number of sig figs when we're figuring out how many sig figs we have, like in adding or multiplying, dividing, or subtraction. Okay, so they we don't take them into consideration. So like if we had something like we're using a conversion factor of 2.54 centimeters equals 1 inch, we'll see later how our number of sig figs can limit how many significant figures we can report in our answer, but conversion factors like these are not going to limit us. Okay, and we'll talk more about that when we get to considering significant figures in our calculations. Okay, so just an overview. Here's all the rules we just talked about. Let's practice identifying some significant figures and some numbers.